Hello everyone, my name is Mukilan. We gonna see the topic about examples for the ductile and brittle material fracture. Okay, the table of contents are fundamentals of fracture, then followed by ductile fracture and their mechanism of ductile fracture, then ductile fracture examples, then followed by brittle fracture as well as then comparison of both brittle and ductile fracture. Then factors affecting the fractures, then ductile to brittle transition, then we will conclude the topic. Here the fundamentals of fractures are the fracture means material separation. That means the separation of material to material. The two separation are called fracture. Then this occurs under applied stress. So normally we take the material and put a load. We will see the deformation. Then it till into the plastic. Then it it will undergo to the fracture. That is called as a fracture. The two main fracture types are ductile and brittle. Then the ductile and brittle modes depends on the temperature. This is depends on only on the depends on the temperature. That means which is the room temperature or elevated temperature depends on high strain rate. These are the fundamentals of fracture. Ductile fractures. We're going to see the ductile fracture. The significant plastic deformation occurs. The importance of flat plastic deformation is very essential for the ductile fracture. The noticeable necking before failure. We will see the necking before failure in the only in ductile fracture. We will not see the necking in brittle fracture. Then slow crack propagation. The crack propagation is very slow in the ductile fracture. The energy absorption is high because of the slow crack propagation. Warning before complete failure. This point is similar to the noticeable necking before failure. So then the common structural metals, which means the construction applications like beams and angles, etc. These are the common structural applications for the ductile fracture. Then the mechanism of ductile fracture is micro-void nucleation occurs. Here we see in the first image, necking is occurred in the first image. Then the void nucleation occurred in the center of the portion. Then the voids are growed. Then the voids are transformed into the crack. Then the fracture will occur. Here we see the micro-void nucleation occurs in the first image. No, sorry. In the second image, we see in the microvoids. Then microvoids are propagated into or transformed into the or growed into big voids. Then we see the growed voids are transformed into crack. Then the fracture will occur. Here uh, we will see call the ductile fracture as a open cone fracture. These are the fibrous fracture surface. We will see in the later image or next previous slide. Mostly the ductile fracture will show like as a fibrous fracture. Shear here shear deformation dominates. Okay, these are the mechanism of ductile fracture. Ductile fracture examples here. Uh, this image is taken from the scanning electron microscope. Here we clearly saw the fibers of ductile fracture. We see here the this is called a cup, this is called cone because of is this rep, represent as a cup and cone. So we see the examples of ductile fracture is a mild steel tension specimen. Mostly this will common material is mild steel, then aluminum rods under tension, then copper wire elongation, and then low carbon structural change. I will seen in previous slide as axles construction structural application. This is applied. Then nickel based alloys, then hard work materials are the best examples for the ductile fracture. Then brittle fracture. Here, little plastic deformation, then sudden catastrophic failure, catastrophic failure, then rapid crack propagation. We see in brittle in ductile fracture, we see it as a slow crack propagation. Here, this is rapid crack propagation. Then low energy absorption. In ductile is high energy absorption. No necking observed because of sudden formation of fracture. Then crack perpendicular to the stress. We will see in the graph as well as this is the mechanism of brittle fracture. Here we see the graph. In x-axis we taken as a strain, in as a percent, then stress as a pascals. The here see these are the elastic limit. In these two, these are the elastic limit. Then the plastic limit. These are the plastic limit. Here we see the brittle fracture. In the in brittle fracture, I will draw the one the diagram. Wait a minute. Sorry, some technical issues. That was been, okay. Okay. In this is the opposites. This is the for brittle fracture. We will see in a ductile fracture later. Okay. These are the elastic limit. We will see in elastic limit. Then cleavage fracture occurs. Mostly in brittle fracture, we will see in only cleavage fracture. Then crack propagates rapidly. We atomic bond separation, low temperature behavior, granular fracture common, shiny fracture surface. In only in brittle fracture, the surface always been like shiny. So in ductile fracture, this not will occur. Brittle fracture examples: cast iron components, glass materials, ceramics under tension, high carbon steels, hardened, hardened tool steels, low temperature steel failure. Most of the because of the carbon percentage in materials, which is leads to the brittle material. So we will get the if we give the load to the material, we will get as a brittle fracture like a cleavage fracture. We will call as a, like a cleavage fracture. Okay, this is taken from also scanning electron microscope. This is called as called or known as a cleavage fracture. Here we see the this image is show how the fracture looks like in brittle nature or brittle manner. This is how the brittle fracture looks like. Okay. Then comparison of both ductile and brittle. Here see the original or engineering stress strain curve was this for ductile fracture, this for brittle fracture. Here the yield point are noted. This is very important for the ductile fracture. This point is ultimate tensile strength point. Then this is our fracture point. This point to this point is known as elastic limit, and this to this is known as plastic limit. This for only ductile fracture. Here we see in brittle fracture, this graph is only upward. Then we get the fracture point. Here no elastic limit or plastic limit, only for elastic and plastic limit only for ductile fracture, not in brittle fracture. Here see we will see in first this image is show how the cup and cone fracture for the brittle material. This is cup and this is no cone. See this image also represent the ductile fracture. We will give the load in upper side, then lower side, this type. Then this is necking, called as necking. This area called as necking. This is cuff and cone type of fracture. This is a brittle material. We has this in cleavage type of fracture. Okay, we will see as a points ductile source necking, brittle source no necking. Ductile absorbs high energy, brittle absorbs low energy, and ductile slow crack growth, brittle rapid crack growth. Because of the carbon content in the material, this will occur because in the material we have high carbon content. We have the very high hardness and as well as wear resistance and strength, which leads to the brittle fracture. If we get we in a ductile material, the carbon percentage are less and some alloy elements are less. In brittle material, as the carbon percentage and other element percentage are high. That's why the fracture is occurring in the brittle fracture is occurring. The cleavage fracture is occurring in brittle manner. Factors affecting fractures: the temperature variation effect, then strain rate influence, material microstructure role. The in both of materials, the microstructure is determine how the fracture will occur. Then grain size important. Grain size importance is very important for the brittle and ductile material. Presence of impurities as well as the homogenization has also play a main role in the material. If we have more impurities, we will get the brittle nature. If we have less impurities, we will get the ductile manner or ductile fracture. Then stress concentration regains. Ductile to brittle transition occurs in BCC metals, temperature dependent behavior, impact loading influence, transition temperature exits, important structural steels, measured using impact test. Then we will see the graph as well. Here the x-axis will temperature, y-axis is energy absorbed. Here we see the person brittle fracture. This is called a DPT. DT means a ductile brittle transition. Ductile to brittle transfer transition. Energy up here. The point is energy absorbed. Here the point is upper transition temperature. Here the point is lower transition temperature. Okay, we will conclude the topic about what we seen in previous class. Fracture behavior critically important. Then ductile fracture safer mode. Then brittle fracture dangerous mode. Then temperature strongly influence the behavior of material in both brittle and ductile. Then material selection is very important for the suitable applications. Applications. If we need a brittle manner, we go for brittle materials. If we need a ductile material, will go for the ductile materials like a composition related phenomena or that like then failure analysis prevents accidents. If we have know the how the energy absorption, how much the load will bear the energy is important for the nature. Okay, thank you for your attention.